Hello students, welcome to distance learning with Nirpendra Acharya, and this video sequencing series and part 3. And if you have missed past part 1 and 2, then you can check the link on description below. We are going to study about sum of arithmetic series. We have discussed about the general term, we have discussed about the arithmetic mean also. Now it's time for sum of arithmetic series. Let's consider an arithmetic series. Now this is an arithmetic series because the gap between the two consecutive numbers is constant throughout the series. You can see 3, the gap between 1 and 4 is 3, 4 and 7 is 3, 7 and 10 is 3. So it is an arithmetic series. Now let's find the sum of first 5 numbers. First 5 numbers means 1, 2, 3, 4, 5 up to 13. The sum, you can easily find the sum, that is 35. Let's increase the number of terms and let's find the sum up to 9 terms, that is up to 25. And we can here also we can easily find the sum as 117. Let's find the sum up to 14 term. Let's increase the number of terms. Now here we have up to 9 term. Now we need to find the sum up to 14 terms. So we need 10th, 11th, 12th, 13th and 14th term. So that is 10th term, 28 is 10th term, 31, then 34, then 37, then 40. Now this is the 14th term. So now we can use our calculator and we can easily find the sum. To find the sum up to 5 term, it was very easy, and up to 9th term also the number were increased, and it took little bit more time. To find the 14th term, it took uh, even more time than to find this 9th term, and to find the 5th term, up to 5th term, sum up to 5th term. So here what we did is we have terms up to 9th term, and we ourselves added 10th, 11th, 12th, 13th and 14th term, and we used calculator, and it took a little bit more time, little bit more times. Now what happens if we try to find the sum up to 25th term, up to 25th term? Now what will be the sum up to 25th term? Now here up to 25 is the 9 up to 9th term, and here you can see 40, it is up to 14th term. Then we have to increase it 15, 16, 17 and so on up to 25th term, and we have to use our calculator, and we can find the sum, but it takes even more time. Okay, it takes more time, and if we increase the number of terms, then it will take more and more and more time. So it is laborious, isn't it? It is a hard work. So isn't there any easiest way? No. Finding term and adding is up to a small number of terms is it's okay, isn't it? We can do it. But if the number of terms increases and it becomes, if the value is large, value of n is large, then it will be really very hard and time consuming to do manually, isn't it? So manually, in sense that to find each and every term and then add it. So I think he seems to know answer. He is smiling. You can see. Of course, there is. We have a formula to find sum of any arithmetic series up to nth term, any number of terms. There is a formula. According to him, according to this guy, there is a formula to find the sum of any number of terms. Okay, uh, we don't have to write each and every term, and we don't have to add them one by one. So What is the formula? Okay, let's see it. We need a formula because formula is needed. Formula will make our work very easier and it will save our time also. So formula is absolutely needed. So let's derive the formula. Sum of arithmetic series. Let us consider a general arithmetic series as, now general arithmetic series you can see T1, T2, T3, T4, T5 and plus plus plus, and in between there are terms, and Tn, that's the last term. Let Sn be the sum of the series. We suppose that sum of the series to be Sn, and okay, then Sn will be T1 plus T2 plus T3 plus T4 plus T5 plus Tn. Okay, now what is T1? So now, as we know that Tn is L, as we have already studied in part 1, that Tn is L. T1 is A, T2 is A plus D, T3 is A plus 2D. We have discussed about this in previous topic, or you can see in previous video. And if you have missed, then there is a link on the description below, then you can check there. Now that is Tn. Now we need Tn is a last term, so we need second last term. So second last term will be Tn minus 1. So let's write then here second last term will be, you can see last term is L. Now the difference between the each and every terms here is D. So the second last term will be L minus D, because D is the common difference, isn't it? So D is the common difference. So difference between the two consecutive terms must be is constant and must be D. So second last term will be L minus D. Now this is our equation 1. Now there is one thing which we have to know. Here 3 plus 2 plus 1 is equal to 6. Now will the result be different if it is done 1 plus 2 plus 3? So as addition is commutative, so we can add a plus b and or b plus a. The result will be same. So there won't be any difference if we add 3 plus 2 plus 1 or 1 plus 2 plus 3 or 2 plus 1 plus 3. And anyway, if we do in any way, then the result won't be different. So we can write the given equation 1 in reverse order. Reverse order means we start from L. Okay, we start from L and we end at A. That's the reverse order. So Sn equal to L, we start with L, then L minus D, then L minus 2D. The third last term will be N minus 2D. So don't get confused. L minus D is the second last term. L minus 2D is third last term. So in this way, we can write L minus 3D also, L minus 4D also. And you can see here, the last term will be A. Now, what we have to do, this is equation 2. And we will add equation 1 and 2, adding equation 1 and 2. So left hand side with left hand side, that is Sn plus Sn, and right hand side with right hand side. You can see A will be added with L, that will be A plus L. A plus D will be added with L minus D. You can add yourself. You can see A plus D, the sum of A plus D plus L minus D. Now see, D will get cancelled and our result, our sum will be A plus L, or you can say L plus A, whatever is written there, it's written A plus L. You can say A is added with L, that is A plus L. A plus D is added with L minus D. You can see here it is also A plus L, and you can try with this also. Add this and this, you will get the same result, A plus L, A plus L, and A plus L, and A plus L. So result will be A plus L. So let's add. It will be on left hand side it will be 2Sn, on right hand side it will be N times A plus L. So how many A plus L are there? There are N A plus L. How we knew this? We have N terms. So the number of A plus L will be N times. Okay. How many terms we have? We have N terms. We have considered our series of N terms, isn't it? We have considered our series of N terms. So there are N times A plus L. So you have to understand how many a plus l are there. There are n a plus l because there are n terms in the series. Now, or Sn equal to n by 2 a plus l. So it is just bringing 2 to numerator of right hand side. Now this is one of the formula, equation 3. We know there is one formula. We know L is equal to Tn is equal to a plus n minus. You are very much familiar with this formula. So we can replace our L with a plus n minus 1d. You can see from 3 Sn equal to n by 2 as it is, a as it is, and instead of L, it's a plus n minus 1d. Let's add a, and we get our next formula, that is 2a plus n minus 1d. Okay, this is equation 4. Now hence equation 3 and 4 are required formula. So this is the formula to find the sum of nth term. Equation 4 and equation 3. Equation 3 we use if we have the last term. Equation 4 in general way, in many times we are going to use equation 4 and 3 also. Okay, now I hope you have understood it. So you can pause the video, you can note it down on your copy. So while noting down in your copy, this part is not necessary to write. Okay, this is just for understanding purpose. Okay, now let's move. Example 1. Now you can see the formula wall. Now it is populated. Right? There are new members. You can see F5 and F6 are the new member. Up to we have studied up to this on video part 1 and part 2. Okay. So F5 and F6 are the new formula. They are the new member of our formula 1. So example 1, very general and very simple question. Find the sum of first 32 terms of series. Find the sum of first 32 terms of series. You can see there is a series there, and the number of terms n is 32. So which formula we are going to use? We are going to use formula 6 because we don't have last term, and so it is very easy to use formula 6. Now let's start our solution. Okay, this question can also be asked as question can be asked in different way. If the first term of arithmetic sequence or series is 12, first term is 12, common difference is minus 3, then find the sum of instead of giving the series itself, if it is given as first term and difference, common difference and number of terms, then also the same technique or same way is used to solve the question. Solution here, you can see the first term a equal to T1, that is first term is a and it is T1 also, so it's 12. You can see it's 12 first term. And second term, that is T2 is 9, and common difference, we know the formula to find the common difference, F1, you can see F1 T2 minus T1, that is 9 minus 12, and which is minus 3. And number of terms, there are 32 terms because we have to find the sum of the 32. So it is n. We know the formula 6, you can see. So let's replace the variables with value n, a, d. We can replace n, a, d, s. N is 32, 32 by 2, and 2. The value of a is 12, value of n is 32, and value of d is minus 3. Okay, now on further calculation, 2 1 are 2, 2 16 are 30, 2 16 are 32, and 12 2 is 24. We can say 32 minus 1, that is 31, and multiplied by minus 3. So now answer is 1100 minus 1104. Okay, this is the answer. Now there are similar type of question for you to practice. Try these questions. Okay, this concludes our example 1. Let's quickly move to another example. Example 2, formula wall you can see on each and every question. So example 2, here we have to find the 12th term and sum up to 25th term. Okay, now the series is given. We can proceed as example 1 solution. Here first term a is 5, second term t2 is 11. Now we know the formula to find common difference, that is d is equal to, you can see formula 1 here, right here, that is d is equal to 2 minus t1. T2 is 11 minus 5, which is equal to 6. Now number of terms to find t12, number of terms will be 12. Here you can see 12, that means value of n is 12. We have number of terms n is equal to 12. So we know the formula, that is f2. We have to use f2 also. F2 tn equal to a plus n minus 1 d. Now t12 equal to a, we have a 5, that is n, value of n is 12 minus 1, d is 6. So we can easily find 12th term, 71. 12th term is 71. You can see hence t12 equal to 71. Now to find the value of s25. Now our n is 25. N is 25. So number of terms, it's not 12, it's 25. We can correct 25. We know the formula, that is formula 6. We are going to apply this formula. Now we can replace the variables with value equal to n with 25, bracket 2a with 5 plus n with 25 minus 1 and d with 6. That is 25 by 2 and bracket 10 plus 24 into 6. Now it is 25 by 2 inside the bracket 154, and the answer is 1925. The sum up to 25th term is 1925. Hence S25 is 1925. So there is one question for you to practice. Try this question. T17 and S8 of the given sequence. Find T17 and S8. You can do exactly like example 2. Okay, now let's quickly move to another example. It's time for example 3. You can see the formula 1 and has 1 and has 2 is written because these two formula are going to be used for the solution of this example. Example 3, you can see the question on your screen. Now there is last term is given. You can see the 17 here, right here. That's the last term. So this question can also be asked as 17 is the last term. So F5, we are going to use F5. And do we have the value of n? Okay, that's a big question. Okay, so to find the value of n, we are going to use the formula F2. Okay, now let's start the solution here. To find the value of n, first we have to find the value of n, because whichever formula we are planning to apply, formula 5 or formula 6, we need the value of n. So we have to find the value of n here. Very easiest way to find the value of n. Now we have first term, second term. It's in mixed fraction, so we have converted it to improper fraction, that is 33 by 4. And common difference d is equal to t2 minus t1. And as you know, our t2 is 33 by 4 minus t1 is 7. So on subtraction, 5 by 4 is our common difference. Last term L is equal to 17. Last term L is equal to 17. So we can use the formula 2, that is L is equal to A plus N minus 1D. We know L is equal to A plus N minus 1D. So we have the value of L, we have the value of A, we have the value of D also. So we can easily find the value of N. Only N is unknown. So 17 is equal to 7 plus N minus 1. And D is 5 by 4. Or now 17 minus 7 equal to 5 bracket N minus 1 upon 4. So 17 minus 7, that is 10, equal to 5. Now you can cancel 5 ones are 5, 5 2s are 10, or you can cross multiply 10 into 4 equal to 5 bracket N minus 1, and that's 40 equal to 5 N minus 1, and we can cancel 5 ones are 5, 5 8s are, it goes by 8 times. So 8 equal to N minus 1. So it's now clear that value of N is 9. Therefore N is equal to 9. So we have value of N. Now you can use any formula, this formula also, this formula also, because there is last term and we have to do less process. So we go for formula 5 to find the value of S9, because there are 9 terms. There are only 9 terms. We have we use the formula F5. We can use F6 also. S9 equal to, now value of N is 9 and A is 7, last term 17, or 9 by 2 into 424. Now we can cancel 2 1s are, 2 2s are. So 12 into 9, that must be 108. So hence the required sum of the given series is 108. Okay, this is the answer. Now you see there are 2 questions for you to practice, and both questions you can do exactly like example 3. Okay, now let's move to another example, example 4. Before that, correct use of formula on different cases. You can see there are 10 questions, and these questions will help you understand how to use formula in which situation, how to use formula in which situation. You can see here there was first question, that is T7 is equal to 29, D is equal to 4. Here we can easily find the value of A, because we have to use the formula 2. If we use the formula 2, we have the value of N, that is 7. We have the value of D. Now only one known will be A, so we can easily find the value of A, and we can find the sum up to 27. So this will help you understand the proper using of the formula, and it will help you to remember the formula also. So I request you to do all these questions. Now example 4. In an arithmetic series, 4th term is 7 and 12th term is 39. We have done this type of question in part 1 of a sequencing series, where we found value of A and D. We do this also in same way, and see first term and common difference A and D, and only this is added actually from previous question. This part is added, some part is added, the rest of the process is same. To find the value of A and D, first we are going to find the value of A and D as we did in part 1. 4 term T4 equal to 7 and N is equal to 4, and 12th term, that is 39 and N is equal to 12. 12th term means 2. Now we have to apply the formula 2. Formula 2 we are going to apply. when n is equal to 4, t4 is equal to a plus, you can directly write 3d here because 4 minus 1d, or t4 is equal to 7, you can see 7 and a plus 3d. Now 7 minus 3d is equal to a. Now this is equation 1. Time will come where we are going to use the value of a as 7 minus 3d. When n is equal to 12, t2 will equal to a plus 12 minus 1d. So where we have the value of t12, that is 39, we are going to use it. 39 is equal to a plus. Now here, this a you can see it's bold. And here also you can see we are going to use, instead of this a, we are going to replace this a right here with 7 minus 3d. So language for it, putting the value of a from 1, we get 39 equal to 7 minus 3d plus 11d, or 39 minus 7 is equal to 8d. Now 8d, the subtraction of this part, that is 32 equal to 8d. A value of d is 4. 8 ones are 8, 8 fours are 32. So value of d is a 4. So from equation 1, if we apply the value of d as 4, then we get the value of a. Now putting the value of d on equation 1, we get, or 7 minus 3 into 4 equal to a, which gives us 7 minus 12 equal to 4, and finally minus 5 equal to a. Now value of a is minus 5, d is 4, so this completes our first part. Hence a is equal to minus 5 and d is equal to 4. To find the value of S15, now we have a, d and n, so we can easily find here number of terms. N is equal to 15, so we can apply the formula f6, last formula f6, or S15 equal to 15 by 2 bracket 2a, value of a is minus 5, as value of n is 15, 15 minus 1, and value of d is 4. So the total sum is 345. You can use your calculator and verify this answer. Okay, there is one question for you to practice. You can do this question as in the same way as example 4, where you have to find first term and d, value of a and d. Then you can find the sum of first 20 terms. The value of n will be 20 in that case. So there is an answer also. So let's quickly, okay, there are more questions for you to practice. Similar type of question, you can say same type of question. Example 5, you can see the question on your screen. In an arithmetic sequence, if 6th term is 64, we have 6th term, that is 64, that is t6 is equal to 64, and we know that t6 is a plus 5d, isn't it? A plus 5d. Then find the sum of 11 terms. We have to find the sum of S11. S11 equal to, this much is there in the question, no more information. So let's start. 6 term t6 is equal to 64, that means n is equal to 6, and we know tn equal to, we can directly write t6 is equal to a plus 5d also. When n equal to 6, a plus 6 minus 1d, that means a plus 5d. Now we have 64, that is t6 as 64, 64 equal to a plus 5d. Okay, this is equation 1. Now to find the value of S11, The value of n is 11. You can see the value of n is 11. We know Sn is equal to, so we can replace n is equal to, when n is equal to 11, S11 equal to 11 by 2 bracket 2a plus 11 minus 1d. We don't have the value of a and d, so we leave them as it is. 11 by 2 bracket 2a plus 10d. Now we can take 2 common. 11 by 2 into 2 bracket a plus 5d. Isn't it? After we take common, 2 common, then it will remaining will be a plus 5d. Now see a plus 5d, that is underlined there. In from equation a also we have a plus 5d. So putting the value of a plus 5d, after cancellation it is 11 into a plus 5d. Now putting the value of a plus 5d from equation 1, the value of a plus 5d is 64. We can apply it as 11 is equal to 11 into 64. Now we have our answer, that is S11 equal to 704. This is our required answer. So it's easy, isn't it? Now try these questions. There are 3 questions and there are answers also. You can follow example 5. You can follow the process as example 5 and you can do all these questions. So example now it's example 6. We did one question where both terms were given and we found the value of a and d. Now in this question you can see both sum are given. In previous question both terms were given and in this question both sums are given. And after this there will be one question where one term will be given and one sum will be given. Okay, understand there are 3 types of question, where in first question uh, both terms are were given. In this question it is just example 6 is the second question. In that pattern, both term sum are given. You can see the both sum are given, sum of first 9 term and sum of 17 terms. In previous question sum of this fourth term or sixth term something was given there. And next question will be, there will be term also, there will be sum also. So in case of term we have to use the formula for term, and in case of sum we have to use the formula for sum. Here both are sums, so we are going to use both F6 formula. Here you can see sum of 9 term, that is 72 and n is equal to 9, and sum of 17 term, that is 289 and n is equal to 17. Now we have our formula, F6 formula. So when n is equal to 9, we start from n equal to 9. Now let's replace n with 9. Only n will be replaced, although we don't have the value. N will be replaced by 9. Okay, S9, that is 72 is equal to 9 2a plus 80. 8, you can see 9 ones are 9, 9 8 is 72. So on cross multiplication 18 to 2. Now we can take 2 common. 16 is equal to 2 common, a plus 40. Now we can cancel 2 and 8 also, 16 also, 8 times, or 8 equal to a plus 40. Now a minus 40, we have to make a alone. A minus 40 is equal to, now when n equal to 17, now here the time will come where we have to substitute the value of a as 8 minus 40. So let's wait for it. For now, n equal to 17, that is just 17 is equal to, we have to replace the value of n as 17 in this formula. 17 minus 1 d, or now as 17 is 289 bracket 2a, that is 16d. Now we can take common also, or we can cancel in this way also. 17 times now we can take common, 2 common from here. Okay, now we can cancel 2 1 2, 2 17 ja 34 equal to a plus ad. Now we can substitute the value of a right here as 8 minus 40. Let's write language. Putting the value of a from 1, we get 17 equal to a is 8 minus 40. Now we have only one variable d, so uh, we are sure that we are going to get the value of d. Or 17 minus 8 equal to 40, which is 17 minus 8, that is 9 equal to 40. 9 by 4 equal to d. Now we have the value of d now, so we can substitute the value of d in equation 1 and we get the value of a. Let's do it. 8 minus 4 into 9 by 4, we can cancel 4 and 4, equal to a, or 8 minus, that's minus 1, 8 minus 9, that is minus 1 equal to a. So we have the value of d also, we have the value of d also, we have the value of a also. So we can easily find the sum of first 25 terms. We have our formula, that is f6. Again, we use this formula thrice in this question. When we can see all this information, when n is equal to 6, a is equal to minus 1, d is equal to 9 by 4. Now we can apply it. Value of d is 9 by 4, bracket close. So sum of first for 25 terms is 650. I hope you understood it. Generally, all questions are done in the same pattern, in the same way. So let's move to another example. Example 7 this time. Here, as I have already told you, here there is sum also, there is term also. First, we did both condition from terms. And second, in a previous example, example 6, we did both conditions are from sum. Now here there will be sum and there will be term also. There are two conditions. You can see the first sum of first is this is the first condition, and 12th term is 47. There is a second two condition, and in first condition there is a sum, and in second condition there is term. So solution, the answer is 990 for this question. Here, as 15 is equal to 465, that is n is equal to 15, and T12 is equal to 47. Here we are going to use formula 6. Here we are going to use formula 2. We have when n is equal to 15, as 15 is equal to 15 by 2, the n will be replaced by 15, and we don't have the value of a and d, so we have to leave them as they are. 465 is equal to 15 by 2, 2a plus 14d. 15 ones are 15, 30 ones are. Or it is 62 is equal to 2. We can take 2 common, a plus 7d. Now we can cancel this 2 and 30, the 62 also, it is 31 times. Or 16, 13, 1 equal to a plus 70. Now 31 minus 70 equal to, you can see the pattern. We arrived at this point in previous question also, in the question before also. This step, we arrived at this step in both of our question, in example 4 also, in example 6 also. Again now we have the formula Tn equal to a plus n minus 1 d. D is missing here, so let me write d. When n is equal to 12, T12 is equal to a plus n. Value of n is 12, 12 minus 1, because we have 12th term, so value of n is 12. 12th term is 47 is equal to a plus 11d. Now you can see the value a here, right here, so we can use, instead of this a, we can use this value 31 minus 7d. Putting the value of a from equation 1, we get the value of a is 31 minus 7d. 47 equal to 31 minus 7d plus 11d. Now we have only one variable, that is d, so we can hope we will get the value of d. Finally, value of d is 4. Now putting the value of d on equation 1, we can get the value of a. (31 minus 7 into 4 equal to a). That is, value of a is 3. So now we have value of a also, we have value of d also, a also, value of d, and we have value of a. Now we can easily find the sum of 22 terms, that is, value of n is 22. We are going to use formula 6 once again. When n is equal to 22, a is equal to 3, d is equal to 4, as 22 is equal to 22 by 2 bracket 2 into a, value of a is 3, plus n minus 1, that is 2 minus 1, and value of d is 4, which is equal to 11. 2 1s are 2, 2 11s are 22, so 3 2s are 6, you can see here, and 21 into 4, that is 84, and the answer is 990. Hence the sum of first 22 terms is 990. Now there is one question for you to practice. 14th term is given and sum also is given in the question. Sum of first 10 term is given and term is also given, that is T14 is given. Don't get confused. Term is, we have to apply the formula of term and we have to apply the formula of sum. So for sum of first 10 terms is given, that means S10 is given, so we have to find the sum of first 20 terms. You can do it as example 7. Now it's time for example 8, student. Now this is very important question. All questions are important. Here also we are going to create a condition. There is sum is given, first 10 term, sum of first 10 term is given. That means we have to apply the formula of sum, that is f6. And there is a condition for the term is given. It's like fifth term. Fifth term is trivial, means 3 times of second term, that is t2. We know that t5 is a plus 4d and t2 is a plus d. Solution here. Now each and every question starts in the same way. You can say s10 is equal to 50, n is equal to 10, and we now have to replace the value of, when n is equal to 10, replace the value of n as 10. s10 is equal to 10 by 2 5 1 ja 5 10 ja. Now or 10 minus 90 equal to 2a. So coefficient of a is 2, so we have to make coefficient of a as 1. Now it's the coefficient of a is 1, so it's equation 1. Now there will be time where we have to use the value of a as 10 minus 90 by 2. Again, according to equation, now we have our condition t5 is equal to 3t2. Now we know t5 is a plus 4d, and 3 times a plus d only. t2 is a plus d. A plus 4d is equal to 3a plus 3d. 4d minus 3d is equal to, or d is equal to 2a. It's equation 2. See, putting the value of a from equation 1. Now this value will be used instead of this a, or d equal to twice bracket 10 minus 90 upon 2. We can cancel 2 and 2, or d is equal to 10 minus 90 plus d is equal to 10. 90 from right hand side will come to left hand side, and its sign will be changed. It's changed now. Now we have the value of d as 1. Now we can apply the value of d in equation 2, and we can, or equation 1, wherever you like. Putting the value of d on equation 1, or you can see the replacement for d 10. Now this is the value of d, it is replaced right here, or 1 by 2 is equal to a. Now we have the value of a also, we have the value of d also. Now we can easily find the sum of first 20 terms. Sn is equal to n by 2 bracket 2a plus n minus 1 d. When n is equal to 20, a is equal to 1 by 2, d is equal to 1, as 20 is equal to 20 by 2 bracket 2 dot 1 by 2 plus 20 minus 1, and value of d is 1. We can cancel this 2 and this 2, and that is 1. And you can see 19, 20 minus 1, so answer is 200. It's an important question. Hence, sum of first 20 terms is 200. Now there are questions for you to practice. Try these questions. Both questions are done like exactly like example 8. Another question. Okay, it's time for example 9 students. It has two parts. First part is understanding part and second part is solution part. First, let's understand the question. Sum of all numbers between 200 and 400. We have to find the sum of all numbers between 200 and 400, but those numbers must be exactly divisible by 7. Now let's start. There is question for you. Is 200 divided by 7 exactly? You can check you can use your calculator and check, and your answer must be no. We can't divide 200 by 7 exactly. Now then find that number which comes after 200. After 200 means 201, 202, 203. Which number is exactly divisible by second? You can 7. You can check with the help of your calculator. First 200, it's not exactly divisible by 7. 201, it is also not exactly divisible by 7. And 202, it is also not exactly divisible by 7. And yes, 203, it is exactly divisible by 3. So that 203 will be our first term. Okay, understand it? 203 is our first term. Now again, is 400 exactly divisible by 7? Check with the help of your calculator and your answer must be no. It is not exactly divisible by 7. Then what we have to do is then find that number which comes before 400. Before 400 means 399, 398. Let's check. With 400 it is not exactly divisible. With 399, yes, it is exactly divisible by 399. 7 is exactly 7 divides 399 exactly. Now that number will be 399 will be our last term. So we have our first term, we have our last term. Now we can easily find. Now what about the common difference? Okay, let's the common difference you can see. Now you can easily recognize the common difference. It is divisible by 7 means just see the table multiplication table of 7. 7 1 is 7, 7 2 is 14, 7 3 is 21. The gap between these numbers 7, 14 and 21 is 7. So the common difference is 7. There is explanation for it. As the numbers are divisible by 7, the difference between them will also be 7. Isn't it? You can see in the multiplication table also. Now the series will look like 203, 210, 217, 214, and the last term will be 399. So this is the understanding part. I think you have understood it. So let's move to the solution part. Solution part, let's recall that series which we have written at the bottom of the previous slide, that is 203, 210, 217, and we have the formula well, and we have to use this formula f2 to find the value of n. Then we can use f5. We have to know that how many numbers are there which are exactly divisible by 7 between 200 and 400. To find the value of n here, the first term we know, that is 203 is our first term, and second term is 210. That is, we can directly write common difference equal to 7, or we can uh, go by the process and we can find the value of common difference, that is t2 minus 2 using the formula t2 minus t1, and 210 minus 203, that is 7. Okay, our common difference is 7. You can directly write 7 also. Now last term we have 399, and we know the formula. You can see the formula 2, L is equal to a plus n minus 1 d. We have L, we have a, we have d. So let's write L is equal to 399, equal to a is 203, plus we don't have the value of n minus 1, and d is 7. Okay, now with simple simplifications calculation, we can find the value of n. 399 minus 203 is equal to 7n minus 7, which is 196 is equal to 7n minus 7, or it is 196 plus 7 equal to 7n. 203 is equal to 7n. We can divide 200, 203 by 7, that is 29 times. That is value of n is 29. Therefore n is equal to 29. So we have the value of n. Now we can use formula 5 also. If you like, you can use formula 6 also, but the formula 5 is short, so we are going for formula 5 to find the value of s29. That is, our last term is 29. There are 29 terms. Not last term is not 29. 29th term is last term. S29 equal to, now value of n is 29. We have the value of a also. We have the value of l also. So we can easily find the sum of first 29 terms. So 2 1 the 2, 301. That 29 into 301, that is 8729. Hence the required sum is 8729. So there are questions for you to practice. Try these questions. There are only three questions. For all questions, the method is same. Okay, method is this is the method for all question 1 2 3 questions. So there are answers also, so you can do these questions. Now let's move to another. Another example, that is example 10. A different type of question, a little bit different types, but the process will be same. The question is on your screen. The first term is 24, last term is 72. Sum of all terms. Now we don't know how many terms are there, but the sum of all terms is 600. That means we have to find the value of n. See, number of terms we have to find, and common difference also we have to find. We can easily find the common difference. Answer is given. And if there are three more terms, than in the previous number, if three more terms are added to the previous number, then we have to find the last term and the sum of the series. So we have to find the four answers. Here we are going to find four answers. Now, first one, case one. Case one is up to here. This part is case one part. To finding of number of terms, n and d is the case one. So to find the value of n first, the first term we have as 24 minus 24. Last term l is equal to 72. Now sum, we have sum of all the terms is 600. We don't know the value of n, so let's use that formula f5. Here you can see it's f5 now, or 600 equal to n by 2 bracket a is minus 24 plus l is 72, or 600 equal to 600 into 2 equal to n, that is 48. Subtraction of minus 24, and here the calculation is 48. 1200 equal to 48n. Now it goes by for 25 times, n is equal to 25. So we have the value of n now, that is 25. You can see the answer is 25. Now to find the value of d, which formula we have to use? We have to use the formula 2. Okay, now we know l is equal to formula 2, l is equal to a plus n minus 1 d. So we have the value of L as 72, and A we have minus 24, plus N we have 25 minus 1, and D. So we can easily find the value of D, or 72 plus 24 equal to 24D. That is 96. 96 is equal to 24D, and value of D is 4. So value of D is also 4. So first case is completed. Therefore D is equal to 4. We have completed our first case. So case 2. In case 2, we have to find the value of L. Now we have the number of terms will be the 25 terms plus 3 terms. You can read this condition again. If there were 3 more terms, there are 25 terms. Now if there were 3 more terms, means the number of terms will be 28. Now we have to find T28. Our last term is T28. We know L is equal to A plus N minus 1 D. We have the value of A minus 24 plus 28. N will be 28 minus 1, and D is 4. So our last term will be 84. So therefore last term is 84. Now one more thing to do, that is we have to find the sum of all series, means we have to find the sum of 28 terms. Now we have the last term also, so we can use formula 5 once again to find the value of S28. So we have to find 3 more terms, means the 6 up to 25 terms. 600 is our answer. So 29, 25 up to 25 terms, the answer is 600, 26, 27, and 20. When 3 more terms will be added, then what will be our sum? Let's see. Sn equal to n by 2 a plus L. That means S28 equal to value of n is 28 now. 28 by 2. L is minus 24 plus L is 84. That is 14 into 60, which is 840. Now 240 is added. The sum between the last 3 terms is 240. Isn't it? Up to 25 terms, sum is 600. Up to 28 terms, sum is 840. Means those 3 terms, 26, 27, and 28, the sum of those 3 terms is 240. Now there is one question for you to practice. There are 4 answers to be found in this question also, exactly like example 10. There is more question in next slide. There is one more question in next slide. This question also we do in the same way. Okay. Example 11. Example 11. Now you can see the question is on your screen. In an arithmetic series, the sum of first 20 terms is equal to that of 30 terms. So it's interesting. S20 is equal to S30. The condition is S20 equal to S30. We know the formula Sn, formula 6. You can see when n is equal to 20, now n is replaced by 20, and value of a and d, we don't have the value of a and d. We don't have the value of S20 also. Leave as it is. Now when n is equal to 30, S30 is equal to 30 by 2, 2a plus n. We have the value of n as 30. So 15 bracket 2a plus 29t. So according to question, you can see the question condition is there. S20 is equal to S30. Now let's replace the value of S20, that is 10 bracket 2a plus 19d. And for S30 also we have 15 bracket 2a plus 29d. We can cancel here and here, that is 5 2 ja and 5 3 ja. Okay, now let's multiply 4a plus 38d, 6a plus 87d. 3 into 29 is 87, or 4a minus 6a equal to 87d minus 38d. Now that is minus 2d, 2a, sorry, 2a equal to 49d, or 0 equal to 2a plus 49d. That is equation 1. Now we have to find the sum of 50 terms. So let's proceed. We know the value of n is 50. So Sn is equal to, we know the formula, that is F6 formula. It is F6 formula. Now only we have the value of n, that is 50. I think you have noticed already 2a plus 49d. You can see 2a plus 49d and 2a plus 49d. What is the value of 2a plus 49d? What is the value of 2a plus 49d? Its value is 0. Now let's put the value of 2a plus 49d as 0 from equation 1, and 25 into 0, which is equal to 0. Hence S50 is equal to 0. Now this concludes our example 11 also. So hope you have understood this question. Example 12. Solution. Here third term is 7 and n is equal to 7. Not 7, it must be 3. Third term is 7, that means n is equal to say 3. So we know third term is a plus 2d. We know third term is a plus 2d, so we can replace the value of t3 as 7 equal to a plus 2d, or 7 minus 2d equal to a. Now the time will come where we have to replace the value of a as 7 minus 2d. Now it is equation 1. We know, see the condition here, 7th term exceed. 7th term exceed means greater. Third term 3 times the third term by 2. Now it's very easy, the language is very clear. Now this is our condition. 7th term exceed the 3 times of third term by 2. 7th term is uh, 7th term is a plus 6d. According to question, t7 equal to a 3 times t3 plus 2. Now we can replace the value of t7 as a plus 6d, and 3 we have the value of third term as 7. A plus 6d is equal to 21 plus 2. A plus 6d is equal to 23. Now we have the value of a as 7 minus 2d. Now let's put the value of a as 7 minus 2d from equation 1. You can see the value of a here and here. It is 7 minus 2d. 7 minus 2d, let's open the bracket. Now we have only one variable, that is d. We can get the value of d now. 7. Now the subtraction of 6d minus 2d is 4d, and 7 goes to another side. 4d equal to 16. Now the value of d is 4. Now we can put the value of d on equation 1. We can easily get the value of a. Right here we are going to replace the value of d as 4. 7 minus 2 into 4 equal to a. 7 minus 8, that is minus 1, is equal to a. Now we have the value of d also, and we have the value of a also. To find S40, we have the value of n, where a equal to minus 1, b is equal to 4, n is equal to 40. It must be 40. Oh, 30 terms means here it is mistake. It must be 30. Okay, S30. To find the value of S30, we know S30 is equal to 30 by 2 bracket 2a, value of a is minus 1, and value of n is 30, 30 minus 1, and d is 4, which gives 15 bracket minus 2 plus 29 into 4, and which gives 1710. The sum of first 30 term is 1710. Hence, S30 is equal to 1710. Okay. Hope you have understood it. Now, for example, 13 student. Now it has two parts. First understanding part and then solution part. Now you can see the question on your screen. Example 13. Solution. Understanding part. It is the understanding part. Now let's read the question again. First term is 5. That means value of a is 5. And the sum of first 5 terms. Sum of first 5 terms means sum from first 5 terms 1 to 5 terms. Sum of 1 to 5 terms is equal to 1/4 of sum of next 5 terms. Next 5 terms means 6 to 10th term. So there is a condition here. Sum of first 5 terms is equal to 1/4 of sum of last 5 terms. The understanding, we have to understand the thing that for first 5 terms our a is equal to 5, isn't it? First term is a and a is equal to 5, and t6 for the next 5 terms. T6 is the first term. Now this is the first term. Now as we know, T6 is a plus 5d, and it is the first term for next 5 terms. This thing you have to understand. For next 5 terms, the first term is T6, and instead of a we have to write a plus 5d. The number of value of n for first 5 terms is 5, and the value of n for next 5 terms is also 5. And you can see the condition how it is developed as 1 to 5 and s 5 to 10. It is 6 to 10. It must be 6 to 10. It must be 6 to 10 equal to 1/4 of s 6 to 10. Now here, while applying the formula for next 5 terms, instead of a, you can see the in formula there will be a. Instead of a, what will be written? It will be written T6, and T6 will be is a plus 5d. For next 5 terms, you can see T6 is at the first, isn't it? So first term is T6. So let's move formula 1. The question, we need our question once again. So solution part for first 5 terms. First term a equal to 5. We know the formula f6 we are going to use. when n is equal to 5 as 1 to 5, first 5 terms, bracket 2 into a is 5 plus n minus 1d, that means 5 minus 1d, that is 5 by 2 bracket 10 plus 4d. We can take common 5 by 2 into 2. After taking common, it will be 5 plus 2d. Now we can cancel 2 and 2. 2 and 2 will be cancelled. Now it will be 5 bracket 5 plus 2d. Now first 5 terms, the sum of first 5 terms is 5 bracket 5 plus 2d. For the next 5 terms, a value of n will be 5. The first term a will be t6, and t6 is a plus 5d, and we can replace the value of a. We have the value of a, that is 5 plus 5d. Now we know the same formula when n is equal to same formula. The value of n is 5. 6 to 10. 2a. A is 5 plus 5d. You can see a is 5 plus 5d. It's not 5. And 5 minus 1d. Bracket close. Or 5 by 2 bracket. Let's open the bracket. 5 to the 10 here, and 2 5 the also. So 10d. Now we can 5 by 2 bracket 10 plus 14d. Now we can take 2 common. 5 by 2. 5 plus 7d. Now we can cancel 2 and 2. 5 bracket 5 plus 7d. Now we can use our condition according to question, as we have already discussed about the condition. You can see the condition on your screen right now. S1 to 5 is equal to 1 by 4 S6 to 10. Now we have the value of S1 to 5 also. We have the value of S6 to 10 also. Or 5 bracket 5 plus 2d. It's written from here. 1 by 4 into 5. It's written from here. We can cancel 5. We can cancel 5 and cross multiplication. We can do cross multiplication. After cancellation, you can see the steps of step after cancellation of 5. And now we can do cross multiplication in this step. 4 bracket 5 plus 2d equal to 1 bracket 5 plus 7d, or 20 equal to 20 plus 8d equal to 5 plus 7d, or 8d minus 7d is equal to 5 minus 20. D is equal to minus 15. We are going to get the value of d as minus 15. So we have the value of a, we have the value of d also, so we can easily find the sum of 40 terms. A is equal to 5, and d is equal to minus 15, n is equal to 40. So we can use our formula 6. Now let's substitute the value. N is 40, 40 by 2, bracket 2a is 5 plus n is 40, 40 minus 1, d is minus 15, and bracket close. So the calculation 20 bracket 10 plus 39 into minus 15 bracket close, and so that the answer will be 11,500. Hence S40 is equal to 11,500. Okay, this concludes our at another example. So let's quickly move to another example. You can pause the video. You have that option. Now example 14. We have 22 examples, I think. Now this is the application of sum of arithmetic series. In a class consists of number of boys whose ages are in AP, and the common difference is 4 months. Okay, there are boys in a class whose ages are in arithmetic progression, and their common difference between the age is 4 months, and the youngest boy in the class is only 8 years old, and we have to, and the sum of the ages of all the boys is 168, and we have to find the number of boys and age of the oldest boy. Now, if we convert into the sequential series quotient, the number of boys is n. Oldest boy means L, or you can say Tn, and the age youngest boy is that is A. Is it common difference, that is of age, that is D. Solution: common difference, we have to convert this into air, that is 4 by 12, which is 1 by 3. With youngest boy A is equal to 8 years. Sum of all ages Sn equal to 168. Now we have the formula. We are going to apply the formula F6. Our formula F6 we are going to apply. We know this is our formula now. Or Sn is equal to 168. You can see Sn is equal to 168. A value of A is 8. 2 into 8. Plus we don't have the value of n, and we have the value of d, 1 by 3. Now in this way we can find the value of n. Only n is unknown, so we can easily find the value of n. N by 2 bracket 16 plus n minus 1 by 3. Now we have to take LCM. 168 equal to n by 2. Now you can take the LCM, that is 16 into 3, because the LCM of 1 and 3 is 3. 168 equal to n by 2 into, that is 48 plus 1 minus 48 plus n minus 1 by 3. 16 3 is a 48. Now we have to subtract 48 and 47 plus n by 3, or 168 equal to 47n plus n square multiplying by n. N into 47 is 47n, and n into n is n square, and 3 to the 6. Now we can cross multiply. 168 into 6 equal to n is 47n plus n square, or n square plus 47n minus 1008. Now 168 into 6 is 1008 equal to 0, or n square. Now what will be inside the bracket? That will be 63n minus 16n. Bracket close, minus 1008 equal to 0. Now let's open the bracket. Here 63 into 16 is 1008. 63 into 16 is 1008, and 63 minus 16 is 47. Now there are 4 terms. We have to take common from first two and last 2 terms. N is common. Remaining is n plus 63, and 16 is common, and remaining will be n plus 63. So n plus 63, we can write n minus 16 and n plus 63, n plus 63 equal to 0, or n minus 16 equal to 0. Either n minus 16 equal to 0 or n plus 16 equal to 0. N is equal to 16, n is equal to minus 63. Therefore n is equal to 16, because number can't be negative. Isn't it? Counting number cannot be negative. Hence number of boys are 16. Now oldest boy, that means we have to use the formula F2. We have the value of A, and we have the value of A, we have the value of D, we have the value of N also. So there are 16 boys. A plus 16 minus 1, D is 1 by 3. You can see that is 13 years. So the oldest boy is 13 years, youngest boy is 8 years. The sum of all 16 boys is 168. Hence the age of oldest boy is 13 years. Now there is one question for you to practice. You can see the sum of their ages is 341 years and 3 months. What we have to do is, in that case, we have to convert that sum in as a year. Sn will be 341 plus 3 by 12. Now you can use your calculator for this. 12 month must be converted to year. This is the way how to convert to year. Okay, there is a similar kind. You can do this question also. A very important question. Question is on your screen. It is example 15. A person pays a loan. It is interest-free loan. A person pays a loan of 3,900 in a monthly installment. Each installment being less than former by 20 rupees. If he pays some amount as a 100 rupees as the first installment, then next installment he will pay 80 rupees. So you can see the amount of first installment is 400. That means in next installment he will pay 380 rupees. In next installment he will pay 360 rupees. And how many installments? Here we have to find the value of n, and the question which will be an example 16-17. There you have to find in one question a value of a also, you have to find the value of l also, you have to find the value of b also. Different types of question will be there. Give reason. There are give reason for multiple answers. There are multiple answers for this question. We have to give reason for it. A solution. Writing the series. Now our series will be like 400 plus 380, as rupees 20 is paid less on each increasing installment. First installment it is 400 is paid, and second installment 380 is paid, and 360 and 20 rupees 20 will decrease on each installment. Now we have our series, then we have our first term also, we have our second term also, we have our common difference, that is minus 20. You can do directly minus 20, or we can use the formula 1. 380 minus 400, that is minus 20. Now we don't have the number of terms, that means installments. Now, but we have the entire, when the entire loan is paid, rupees 3,900 is paid, so we have Sn, sum paid on all installment. If we add the sum paid on all installment, it will end up as 3,900. So our sum of n terms is sum of all installment is 3,900. So we know the formula, that is formula 6 right here, or Sn, that is 3,900. Okay, it is a replacement of a, it is a replacement of d. Now 2 into 400, that is 800, and while multiplying n and minus 20, it is minus 20n, and 1 and minus 20, it is plus 20. Now if we multiply 2 into on cross multiplication, 2 into 3,900, that is 7,800, and we can add 820, it is 820. Now we have to open the bracket from here. It will be 820n minus 20n square. Now all term will go to left hand side. 20n square minus 820n plus 7800 equal to 0. Now 20 will be common. In bracket n square minus 41n plus 319 equal to 0. 90 equal to 0. Or n square minus 41n plus 390 equal to 0, as we know that 20 is not equal to 0. So what must be 0? Our next part must be 0. That is this part must be 0. there are two factors, 20 and n square minus 41n plus 390. There are two factors, and among these two factors 20 is not equal to 0. You can see 20 is not equal to 0, so that means that second part must be 0. Or factorization, we have to find two numbers which when multiplied will be 390, that is 26 and 15, and when added it will be 41, that they are 26 and 15. Now let's open the bracket and be careful, there is a minus sign here, so it will change the sign. You can see the sign is changed to minus sign. Or and bracket, there are four terms, so we have to take common from first two term and last two term. From first two term n is common, that is n minus 26 is remaining, 15 is common, n minus 26 is remaining. So n minus 26 bracket n minus 15. Either n minus 26 equal to 0 or n minus 15 equal to 0. Now we know the value of n is 26. Also the value of n is 15. So both are positive, both numbers are positive. So, and out of these two only one is our answer. So we have to explain why other is not our answer. So let's check, let's find the last one. How much amount he will pay in his last installment. We are going to find how much amount he is going to pay on his last installment. If we consider 26th installment as last installment, then what will be the amount he paid on last installment? That is 26 minus 1, that is 25. And here, if 15th installment is the last installment, then how much money he paid in last installment? Let's see. That is minus 100, negative value, and here you can say 120. When 15 is our last installment, then he paid 120 as last installment, and when 26th installment is our last installment, he paid minus 100, negative value. You can't pay negative amount, so it is not practical. This is the region part. Okay, you can see this is the region part, and it is practical. In last installment 120 can be paid, negative value cannot be paid, so hence the entire sum is paid in 15 installments. So our answer is 15, not 26. So this concludes our example 15, very important example. So there are questions for you of similar kind. There are 4 questions, very important question, very important question for SE point of view. Now let's quickly move to slide 28 and example 16. This question is also very important. How much V you want to add to the question? A contractor on a construction job specify a penalty for delay of completion beyond a certain date. Now, if it was written in the agreement that work must be completed on 30 days, then if the contractor is unable to complete the work in 30 days, and if it takes 31 days, means one day more, then he have to pay a rupees fine, as 200 as rupees fine. But if the day increases, the additional day increases, it goes to 32 days, then he had to pay in next day 50 rupees more, that is 250. And in the same way, in the third day he has to pay 300 rupees, fourth day and 50 rupees, that the the pattern increases in that way. Okay, 200 for the first day, the fine of delay 200, 250 for second day, 200, 300 for third day, and 350 for fourth day. In the same way. Now, if he has delayed the work for 30 days, and how much total amount he have to pay as a penalty? Okay, so let's find. First, we have to create a series. Our series will look like 200. It is a fine for first day, 250 for second day, and 300 for third day. Now you can see the gap is 50. So 50 rupees increased in each delayed day. Now first term you can see that is 200. Second term is 250. Now common difference, that is 50. Number of terms, that is number of days, delayed days is 30. So number of terms is 30. We know Sn is equal to n by 2, 2a plus n minus 1d. The question looks difficult, but the solution you can see how easily we can do. You can see value of n, value of a, and value of d is replaced. Value of n is replaced here, and value of d is replaced here. Value of a is replaced here. Value of n is replaced here. So all the replacement process. So we move quickly from there. Now it is 15 into 1850. The answer will be 27,750. Now he had to pay, the contractor has to pay 27,750 as penalty. Hence, if the work is delayed for 30 days, contractor had to pay the penalty of rupees 27,750. If you understand the question properly, then solution C, just a simple use of two formula actually, and here one formula and here one formula. So there are questions, a similar type of question for you, only one question. 5 mark question. This type of question will be asked as a 5 marks question. Higher ability question. It is just based on the understanding. If you understand the question properly, you can do it easily. Okay, let's move to another example. Example 17. Question looks difficult. Okay, let's quickly move to question. You can see one secure and interest-free loan of this. It is a loan. It must be paid on installment. So one agrees to repay in 10 installment. We have the number of installment right here, but in previous question there was we found the number of installment. He pays rupees 100 as a first installment, then increases the installment on equal amount over the preceding installment. What will be his last installment? We have to find the value of L. Okay, now can you guess which formula we are going to use? We don't have the difference on the installment. Increases installment by equal amount. Okay, that we don't know that amount, and we have not asked here in the question also to find that amount. So we don't have the value of D. So the formula which is free of D is F5. So we are going to use the formula F5. Total sum to be paid is 14,500. It is interest-free loan and number of installment. It is completed in 10 installment, and amount paid at first installment is 1,000. You can see 1,000 is paid, and we don't know the value of D. Last installment we have to find out. So this formula must be used. We know Sn is equal to n by 2 bracket a plus L. So Sn is 14,500 is equal to, and value of n is 10, and value of a is 1,000 plus L. That is 14,500 equal to 5, 1,000 plus L. Now we can cancel it. How many times? 290 times. 2,900 times. Or 2,900 equal to 1,000. Question looks difficult, but we have almost completed it. And L is equal to 1,900. Hence the last installment is rupees 1,900. So he paid. Now we have still to do few questions where we have to find the first installment and D also. We have to do the two more questions related to find the value of first installment and to find that equal increment in every installment D, value of D, A and D. We haven't done this type of question. Now let's quickly move to another slide. You can see example is 18 and our slide is 30. The starting salary of a man is 20,000 and it increases by 2,000 each year. Find his salary in ninth year. And this type of question we have already done. If you convert this question as a form of sequential series, then the value of A is given, you can see, and value of D is also given. Now, what we have to find is we have to find the T9 salary on the ninth year, and total salary means S9. So we can easily do this question. Now, let's write the series. Wherever it is possible, we have to write the series. Writing the series, that is 20,000 plus it increases by 2,000 every year, means next year or 12 months he will get 22,000 salary, and for another year 24,000 throughout the year. Now we have our first term, we have our second term, we have common difference also. Now T2 is 22,000. We can directly write 2,000 as common difference. Now salary in ninth year, that is T9. Number of year is 9, so T9 we know T9 equal to, we have the value of A, that is 20,000, and we have the value of N, that is 9, and we have the value of D, that is increment, is 2,000 per year. So 20,000 plus 8 into 2,000, that is 16,000, that is rupees 36,000. And in the ninth year, he is going to receive 36,000 as his salary throughout the year. Now, how much total salary he gained or he received? You can see hence the salary in ninth year is 36,000. Total salary in ninth year, number of terms n equal to 9, and we know which formula to use, that is formula 6. Now we can replace the value as 9 is equal to, we have the value of n as 9, and bracket 2a is 20,000 plus n is 9, 9 minus 1, and d is 2,000. Now 9 divided by 2, that is 4.5, bracket 40,000 plus 8 into 2,000, that is 16,000. 4.5 into 56,000, which will be the total salary he has earned in 9 years will be 2,52,000. Hence total salary in 9 years is rupees 2,52,000. There are questions for you to practice. Try these questions. Both questions will be done exactly like example 18. Now let's move. Questions for you, similar kind of questions, similar type of question. You can do these questions also. Example 19. Now understand this question. The firm produces 100 calculator set during the first year, that is the value of A, and total number of calculator set produced at the end of 5 years, that is S5. It is S5 at the end of 5 years. Assume that the production rate production increases uniformly, means in equal amount. Estimate the increase in production, that is D. You have to find the value of D. Now, as I have already told, we have to solve the question where we have to find the value of D also, A also, L also, and n also we have already done that type of question where we have to find the value of L, we have to find the value of D, sorry, not D, we have to find the value of L and N. Production on the first year is there. Increase in production in each year, that is D. Now we can easily use this formula F6 and we can find the value of D. Why we are not using F5 formula? Because F5 is independent of D. Okay, it's free of D. Okay. Value of N is 5. We can write here when N equal to 5. 900 times, or 900 into 2, that is 1800, equal to 200 plus 40. Now we can easily find the value of D. Or 1600 equal to 40. 400 equal to D. Hence, increase in production each year is 400 calculator. Hence, increase in production each year is 400 calculators. Each year, the production increases by 400. First year, it was 100, and second year, it is 500, third year, it is 900. Okay, in this way, the series develops. Example 20, we have 22 examples. Now, you can see the question. Here we have to find the value of A. Okay, now see the question. To pay a sum of money amounts to rupees 3900 to a finance company, that is loan, that means it is as n. If we have the value of n, then it takes 20 months, means n equal to 20. The value of n is 20, and Sn equal to 29,000. 29,000 is taken as a loan, interest free loan. It must be it is, I think it is interest free loan, or whatever loan it is. It is 29,000 is loan, and it is completed in 20 months, or you can say 20 installment, and in each month rupees 100 more is paid. That means in first installment what is ever is paid, and next installment 100 rupees is added. Okay, now if in each installment 100 more is paid, find the amount that should be paid in the first installment. And if we construct our series roughly, then it is A, and next it is A plus 100, A plus 100, and next it is A plus 200. Okay, you can write series also, A plus 200 and A plus 300. So our common difference is in this way. It is series, so we can write plus sign here, bracket and plus sign, bracket and plus sign, and bracket. Now this is the series. We have to find the value of A. So total number of money to be paid in 20 months, that is S20 is equal to 29,000 and N is equal to 20. Amount of first installment A is equal to what? Increment in the payment per installment, that is 100, we know. $29,000 is equal to N, that is 20 by 2, bracket 2 dot A plus N minus 1, that is 20 minus 1, and we have the D, that is 100. Now we have only Now, first installment is 500 is paid as first installment. So the question is very easy if you understand it properly. Amount paid on first installment is rupees 50. Now there are two more examples. So let's quickly move to those examples. This is the arithmetic sequence. Here we have to find the value of p, then we can find the sum of first 5 terms. Okay, that is 55. Answer. Solution. Here t1 equal to p plus 2. Similarly t2 second term is 2p minus 1, and our third term is p plus 6. We have common difference d is equal to t2 minus t1, that is 2p minus 1, that is it's the value of t2 and it is the value of t1. Okay, now let's open the bracket. 2p minus 1 is equal to 2p minus 1 minus p minus 2, and it is p minus 3. Now common difference, again we have to find the common difference. It is equation 1, and common difference again our formula can be t3 minus t2 also. Here the formula can be further expanded as t3 minus t2. So this is the value of t3 and this is the value of t2. Now let's open the bracket. The sign is changed. Here you can see plus. Now 7 minus p. Both equation 1 and 2 refers to the same common difference, so they will be equal. This value and this value will be equal from 1 and 2. P minus 3 equal to 7 minus p, or p plus p equal to 7 plus 3, sorry. 2p equal to 10, p is equal to 5. Therefore p is equal to 5. Now again we have to find the value of a, that is first term, by putting the value of p. t1 is equal to a, p plus 2 is equal to 5 plus 2, that is 7 equal to a. Now first term is a, value of a is 7, and we still need common difference also. For this you can use this p minus 3 or 7 minus p. So p value of p is 5. Now 5 minus 3, that is 2. We have common difference. We have a. Now we have 5 terms, means we have value of n, so we can easily find s5. To find s5, we can easily find s5. We have, this is the formula, f6 formula. We have to use this formula. When n is equal to 5, a is equal to 7, and b is equal to 2. Now let's replace all these values. .5, 5 divided by 2, 14 plus 8, 4 into 2, 8. 2.5 into 22, that is 55. Okay, now sum of first 5 term is 55, means the value of p is 5 and s5 is 55. Now there is one question for you, similar type of question to practice. Try this. Next question, last question. Example. You can see the question on your screen. Example 22. Now first term and 20, sum of first 20 term we have to find. You can see here the sum of first 6 term, that is s6. s6 is 42, and value of n is 6. And the ratio of 10th term and 30th term, that means T10 upon term, isn't it? So we have to use T, and 30 term is ratio is 1 by 3. Now we can easily do this question. Let's start here. T6 is equal to 42 and equal to 6. So we have our formula. When n equal to 6, as 6 is equal to, only we have the value of n only, so a and b will be as it is, or as 6 is 42, 42 equal to 3 and 2a plus 5d. Now we can cancel 3 and 42 14 times, or 14 minus 5d is equal to 2a. We'll just leave as it is. Now again we have another condition. According to question, T10 by T30 is equal to 1 by 3. We know that T10 is a plus 9d, isn't it? A plus 9d, and T30 is a plus 29d is equal to 1 by 3. Now cross multiplication. Let's do cross multiplication. 3 bracket a plus 9d is equal to 1 a plus 39d. 29d. 3a plus 27d equal to a plus 29d, or 3a minus a. I think up to here it is clear. 3a minus a equal to 29d minus 27d. Sorry, it's not equation here. Or 2a equal to 2d. So it must be equation 2. Now we have the value of 2a. We have the value of 2a as 14 minus 5d. Let's replace from 1. 14 minus 5d is equal to 2d, or 14 equal to 7d. 2d plus 5d, that is 7d. 14 equal to 7d. D is equal to 2. So putting the value of d on equation 1, we get, or 14 equal to, we have the value of d, so we can substitute the value of d on equation 1, that is 14 minus 10. Value of a is 2. So we have value of a and we have value of d, so we can easily find the sum of first 20 terms. To find S20, we have our formula, Sn formula, F6 formula, and when this we have these values, n equal to 20, a equal to 2, and d equal to 2, we can easily find S20. Now the sum is 420. Hence, first term a is 2 and S20 is 420. So this concludes our part 3 of sequencing series. For part 1 and 2, you can check the link on the description below. Thank you for being with me. And it is almost a 2 hour of journey with 2 hour of study actually, and hope you have understood everything which we have done here. And don't forget to like, subscribe and share, and more videos will follow on coming days. Thank you.